In the lexicon of naval warfare, the super dreadnought was the ultimate expression of national power.
At 9:40 p.m. on February 15, 1898, the peace of Havana Harbor was shattered. The USS Maine, an armored cruiser representing American power, erupted in a catastrophic explosion. Over 260 sailors, the vast majority of her crew, were killed instantly as the forward third of the warship folded in on itself. The public cry was immediate. "Remember the Maine, to hell with Spain." The explosion was declared an act of war, the work of a Spanish mine. But from the moment the first divers surveyed the mangled wreckage, the physical evidence told a different story. The ship's bottom plates were bent outward, not inward, as an external mine would have caused. This single, damning piece of forensic evidence suggests the Maine was not murdered, but that it died by its own hand. It was a catalyst for war, built on a forensic lie. This is the story of the USS Maine and the engineering flaw that sealed its fate. We will dissect how it was designed and why it failed. To understand the Maine's destruction, we must first understand the world she sailed in. The year 1898 was the peak of new imperialism. The great powers were engaged in a global scramble for territory, and the United States was eager to join the ranks of empire. The tinderbox was Cuba, just 90 miles off the coast of Florida, which was fighting a brutal war of independence against its colonial master, Spain. American yellow journalism, led by newspaper magnates William Randolph Hearst and Joseph Pulitzer, fanned the flames of war. They published sensational, often fabricated, stories of Spanish atrocities, whipping the American public into a pro-war frenzy. Spain was painted as a tyrannical, decaying empire, and America as the righteous liberator. Into this powder keg sailed the USS Maine. She was not a first-rate battleship, but a new, fast, second-class battleship. Often designated as an armored cruiser, she was a symbol of the new American steel, not a tool of gunboat diplomacy. Her mission to Havana in January 1898 was officially a friendly visit to protect American citizens and property. But everyone understood its true purpose. It was a veiled threat, a steel fist in a diplomatic glove. The Maine sat at anchor in Havana Harbor for 3 weeks, a visible projection of American power in a Spanish port. The tension was palpable. Spanish officers felt insulted. Cuban rebels saw a potential and dangerous ally. The ship was an object of intense suspicion. When she exploded, the political machinery was already primed for war. The American public and its press didn't want a complex engineering investigation. They wanted a villain. Spain was the obvious culprit, and the cry, "Remember the Maine," became a political justification, not a forensic conclusion. This immense political pressure demanded a simple external causa, mine, and it led the first naval court of inquiry to overlook the fatal secret hidden deep within the Maine's own hull. The USS Maine was a vessel of compromise, a machine built in a transitional era. She was one of America's first steel battleships, yet her design was already being eclipsed. She was not a true pre-dreadnought. Her main armament was mixed, with 10-inch guns in 2 offset turrets and a secondary battery of 6-inch guns. This hybrid design reflected a navy still experimenting with the future of sea power. But the Maine's most significant features were not her guns. They were her guts. Like all ships of her day, she was a coal-powered steamship. Her beating heart was a set of vertical triple-expansion steam engines, fed by 8 single-ended Scotch boilers. To fuel these boilers, she carried over 800 tons of bituminous, or soft, coal. Here, in this 3D cross-section of the ship's forward half, we can see how this coal was stored. It was packed into bunkers, that lined the hull, acting as an additional, though unintentional, layer of protection. But this coal had a well-known and dangerous property: spontaneous combustion. Bituminous coal, especially when stored in large, poorly ventilated piles, can slowly oxidize. This generates heat, which, if not dissipated, builds relentlessly. This was a common problem on warships. Bunker fires were a constant, nagging threat, often smoldering for days. The Maine's second critical component was her ammunition. Her magazines were filled with shells, and more importantly, the propellant. Brown-black powder. This was not the stable, modern, smokeless powder or cordite that would soon become standard. This older powder was notoriously unstable. It was highly sensitive to shock, and most critically, to heat. Naval regulations at the time were clear. These magazines had to be kept cool and isolated from heat sources. Now, let us bring our forensic analysis to the Maine's blueprints. When we overlay the ship's coal bunker plan with the ammunition storage plan, the fatal flaw becomes immediately, shockingly apparent. Here, in the forward section, is the 6-inch reserve magazine, and right here, sharing a single, uninsulated steel bulkhead, is coal bunker A16. This is not a minor oversight. It is a catastrophic design failure. A magazine filled with heat-sensitive explosives was placed directly adjacent to a bunker filled with material known to spontaneously ignite. A single, 516-inch steel plate was all that separated a potential inferno from a high-explosive payload. The 1898 inquiry noted that the magazines were inspected daily and their temperatures logged. But they missed the point. They were logging the air temperature. The real danger was conductive heat, traveling directly from a smoldering hotspot in bunker A16 through that common bulkhead, and silently, invisibly, cooking the brown powder on the other side. The Maine was a time bomb, designed and built by her own Navy. All it needed was time. The Type 99, however, utilized a base-mounted delay fuse specifically, the Type 92. This mechanism was timed to trigger 0.2 seconds after impact. To the layman, 0.2 of a second is instantaneous. To a forensic engineer, it is an eternity. At terminal velocity, moving at nearly 260 meters per second, that 0.2 second delay allowed the bomb to travel an additional 50 meters after striking the ship. This ensured that the detonation would not occur on the deck, or even the deck below it. The explosion was mathematically programmed to occur deep within the bowels of the ship, inside the very citadel that was supposed to remain impregnable. The Arizona was a fortress built to stop a spear thrown from the horizon. The Type 99 was a dagger dropped from the clouds. On that Sunday morning, these two incompatible eras of engineering were about to collide. At 08 a.m., a formation of Nakajima B-5N Kate bombers from the carrier Kaga leveled out at an altitude of 3,000 meters. Among them was Petty Officer Noboru Kanai, regarded as the most skilled bombardier in the fleet. Below him, the Arizona was stationary, her boilers offline, her damage control conditions set to a peacetime standard. Because the ship was moored, Kanai did not need to calculate lead for a moving target. He only had to account for wind drift and ballistics. At 08:06, he released the toggle. Gravity took over. The 800-kilogram projectile began its descent, accelerating for nearly 10 seconds until it reached near terminal velocity. As it screamed toward the harbor, it ceased to be a bomb and became a kinetic pile driver. Forensic reconstruction places the point of impact on the starboard side of the upper deck, frame 26, just alongside the barbaric mass of turret number 2. This is where the all-or-nothing armor scheme faced its reckoning. The bomb struck the polished teak deck, smashing through the thin, mild steel beneath it as if it were paper. It continued downward, entering the structural void of the ship. Here, it likely glanced off the faceplate of turret 2. Instead of shattering, The hardened steel casing of the Type 99 deflected inward, correcting its path deeper into the vessel. It punched through the main deck, then the splinter deck. It was now traveling through the ship's internal anatomy, faster than the crew could register the sound of the impact. Finally, it encountered the armored deck, the ship's primary horizontal shield. But the angle was too steep and the velocity too high. The bomb perforated the armor plate, entering the forward distribution spaces. The 0.2-second delay timer ran out. The detonation did not occur inside the main 14-inch shell magazine, but slightly above it, in a compartment used to store black powder. This is a critical forensic distinction. Modern smokeless powder is relatively stable. It requires a significant thermal shock to ignite. Black powder, used for aircraft catapult charges and saluting guns, is highly volatile. The bomb's explosion was the primer. It instantly ignited the black powder stores. This created a localized flash fire of intense heat and pressure that burned through the bulkheads, separating it from the main magazine. Inside the forward magazine, hundreds of tons of silk bags filled with smokeless propellant were stacked floor to ceiling. When the flash reached this room, the physics of the Arizona inverted. The propellant didn't just burn, it deflagrated at supersonic speed. The resulting gas expansion created an overpressure event so violent that it exceeded the structural yield strength of the entire forward hull. Witnesses described the ship appearing to jump out of the water. This was not an illusion. The force of the blast severed the bow from the rest of the ship.
The forward hull expanded like a balloon and then shattered, venting a column of flame and debris 500 feet into the air. The explosion was so comprehensive that it extinguished the fires in the boiler rooms simply by consuming all the oxygen in the vicinity. The blast wave collapsed the decks downward, pancaking the interior compartments. The heavy armored turrets, weighing hundreds of tons, dropped nearly 20 feet into the void where the hull used to be. In less than 7 seconds, the USS Arizona went from a combat-ready super dreadnought to a burning reef. The system hadn't just failed, it had been deleted.
The destruction of the USS Arizona is often cataloged as a failure of intelligence or military readiness. But when we view it through the lens of systems analysis, it reveals a much colder truth. It was a failure of imagination in naval architecture. The tragic flaw was not a mistake in the welding or a defect in the steel. It was the all-or-nothing armor doctrine itself. This philosophy was predicated on the assumption that the decisive blow would come from another ship firing from the horizon. It assumed warfare was a two-dimensional affair, fought on the surface of the sea. The Japanese attack introduced the third dimension, verticality, and the Arizona was simply not built for this geometry. The disparity between her 13.5-inch belt armor, designed for shells, and her 5-inch distributed deck armor, designed for splinters, created a protection gap. The Type 99 bomb was not a superweapon. It was merely a kinetic key that fit that specific lock. The sinking of the Arizona did more than cripple the Pacific Fleet. It practically ended the era of the battleship in a single second. It proved that a $200 modification to an artillery shell, delivered by a cheap single-engine aircraft, could annihilate a $13 million capital ship. The economic and tactical calculus of naval warfare had shifted irreversibly. The dreadnought, the master of the seas for arguably 400 years, was instantly demoted to a support vessel. The aircraft carrier, absent from the harbor that morning, ascended as the new monarch of the ocean. The Arizona was the final sacrifice of the old world, destroyed by the first strike of the new one. To this day, the hull of the Arizona weeps oil into the harbor, the black tears of the Pacific. It is a slow-motion bleed from a wound inflicted in 1941, a persistent chemical reminder of the violence of that morning. She remains commissioned, not as a weapon of war, but as an eternal underwater mausoleum, resting exactly where the math of a new era proved her obsolete.